In this section, we are going to talk about algebraic methods of solving a pair of linear equations. We'll start with substitution method, then we'll talk about elimination method, then we'll talk about cross multiplication method, and we'll also look into some examples throughout. So let's start with substitution method. Substitution method is based on representing one variable as another. So what happens? Usually you get pair of linear equation in two variable, right? So that means you have two equation. You can pick any of one which is simpler and then try to express one variable in terms of other variable, and then take the value of the variable which has been expressed and put into the other equation which you have not used, and then try to convert them into equation with just one variable because it is easy to solve, and then get the value and then use this value again to get values for other variable. So here is the step. Find the value of one variable. Let's take an example. In this case, let's say that variable is y in terms of other variable, and let's take an example of x from either equation, whichever is convenient. All right. Then the next step will be substitute this value of y in the other equation, the equation which was convenient for you to get the value of y in terms of x. Apart from this, there is one more equation. Use that equation and substitute the value of y in that equation. Reduce it to an equation in one variable, that is in terms of x, which can be solved. Next, substitute the value of x obtained in step 2 in the equation used in step 1 to obtain the value of other variable. Now let's try to understand this through an example. We are trying to solve pair of linear equations 7x minus 15y equal to 2 and x plus 2y equal to 3 by substitution method. So here we have these two equations as given, right? So step 1, I'm going to look into these two equations and pick the simple equation. And the simplest equation in this case is x plus 2y equal to 3, which is my second equation. And we'll try to represent one variable as another. So in this example, x plus 2y equal to 3. And if I take 2y on the left hand side, I'll get x equal to 3 minus 2y. And let's call this equation 3. Now, as part of step 2, I'm going to take the value of x from equation 3 and put this in equation 1. And what I'm going to get is 7 multiplied by x is basically 3 minus 2y minus 15y equal to 2. Which then, if you simplify this, you'll get 21 minus 14y minus 15y equal to 2. Which then gives you 21 minus 2 equal to 29y. And hence, y is equal to 19 by 29. So step 2 is performed, and now I got value of y. Now I'm going to take the value of y, substitute this from 4, the value of y from 4 into the value of x in equation 3, like what we get in step 1, right? So once I do this, I'm going to get x equal to 3 minus 2y, which is 2 multiplied to 19 by 29, which will give me 49 by 29. And now I have the value of x and y. We can verify this as well. If I put x equal to 49 by 29 or y equal to 19 by 29 in any of this equation, my left hand should be equal to right hand side. So let's try with example 2, right? So example 2 was x plus 2y on the left hand side. So LHS is equal to 49 by 29 plus 19 divided by 29. And when you simplify this further, you get 49 plus 38 divided by 29, which gives you 87 divided by 29, which then get divided and simplified, and what you get is 3, which is nothing but equal to right hand side, and hence this is verified. Now let's talk about elimination method. Elimination method is based on removing one variable and solving for equation in one variable. So basically in substitution method, we were substituting it one variable by another variable. The intention was to get a simple equation in one variable which can be solved. Here you are removing that variable itself, and then the output will give you equation in one variable, which is again simple to solve, and then we'll go from there. So what are your steps? First, multiply both the equation by some suitable non-zero constant to make the coefficients of one variable, at least one variable, right? Either x or y, numerically equal so that you can use them to cancel it. The step 2, add or subtract one equation from the other so that variable gets eliminated. So one of the variable get eliminated, right? Step 3, solve the equation in one variable, x or y, whatever you get after elimination, and so obtain the value of it. And step 4, substitute this value of x or y in either of the original equation to get the value of other variable. Now let's take an example of it, right? So in this example, we'll solve 2x plus 3y equal to 8 and 4x plus 7y equal to 7 by elimination method. We have 2x plus 3y equal to 8, 4x plus 7y equal to 7. Let's consider them as equation 1 and 2. Now we go to step 1 where we want to multiply equation 1 by 2 and equation 2 by 1 to make coefficient of x equal, right? So I'm multiplying 1 by 2 and equation 2 by 1 to make coefficient of x equal, right? So now what I'm going to get is 4x plus 6y equal to 16 when I multiply 2 to equation 1, and let's call this at equation 3, and what I get is 4x plus 7y equal to 7 when I multiply 1 to equation 2. Now this step is not needed because multiplying by 1 is same as equation 2 itself. So if you need, you can just ignore this step. You can directly use equation 2 and 3. Now subtract equation 4 from equation 3. What you get is 4x plus 6y minus 4x plus 7y equal to 16 minus 7, which then gives you 6y minus 7y equal to 9. Now we go to step 3 where we'll solve the equation in one variable, which is this 6y minus 7y equal to 9. And hence I'll get y equal to minus 9. Now if I substitute y equal to minus 9 in equation 1, what we get is 2x plus 3 multiplied to minus 9 equal to 8, which will give me x equal to 35 by 2. And hence now I have y equal to minus 9 and x equal to 35 by 2 as a solution for pair of linear equations. Let's take one more example where we are trying to solve 2x plus 3y equal to 8 and 4x plus 6y equal to 7 by elimination method. Here again we have same equation 1 and equation 2, and now when we multiply 1 by 2 and equation 2 by 1 to make coefficient of x equal, what we get is 4x plus 6y equal to 16 and 4x plus 6y equal to 7. When you subtract 4 from equation 3, what you get is 4x minus 4x plus 6y minus 6y equal to 16 minus 7, and it is going to give you 0 equal to 9, which is not right. So it's a false statement. What does it mean? This means The pair of equation has no solution. So you cannot really solve these two and find a value of x and y. Now let's talk about cross multiplication method. This is interesting. Cross multiplication method works for a pair of linear equation in two variables, and this is my equation 1, a1x plus b1y plus c1 equal to 0, and another equation is a2x plus b2y plus c2 equal to 0. Now cross multiplication method says the value of x, y and c, which is constant term, are correlated in a specific pattern, and the pattern is I can represent x by b1 multiplied to c2 minus b2 multiplied to c1 will be equal to y divided by c1 multiplied to a2 and c2 multiplied to a1. That is going to be equal to 1 divided by a1 multiplied to b2 and a2 multiplied to b1. So it is basically what we are doing here. We are following a cyclic pattern to get into an equation of x, y and constant term divided by the coefficients of pair of linear equations. Let's try to understand one more time what we did. So when you take x, so you basically are trying to find out value of x and y. So we'll write x, y, and for the constant term we'll write 1. Now I have to get what do I divide x with, y with and the constant term with, right? So when you represent x, you can ignore all the coefficient of x and you can just look into b and c, the coefficient of y and the constant term, and then you multiply b1 to c2 and subtract b2 to c1. When you go to y, you're going to ignore the coefficient of y and you will go in the cyclic pattern and you will say c1 multiplied to a2 and c2 multiplied to a1. And when you go to constant term, you ignore c1 and c2 and then look into a1 multiplied to b2 and a2 multiplied to b1. There is other way to represent this. You can also represent it as x, y and 1. And when you are looking for x, ignore the coefficient of x. Write b1 c1, b1 c1 and b2 c2, b2 c2, right? Then you go to y, ignore coefficient of y, and then you write c1 a2, c1 a2, and you write c2 a1. Then you go to constant term, ignore the coefficient of constant term and look into a1 to b2, a1 to b2 and a2 to b1. So basically you are going to write x, y and 1 for constant term. You are going to write b1 c1 because you just ignore this. You write b1 c1 and in the below you write b2 c2, b2 c2, right? Then you go to y and you write c1 c2, c1 c2 and a1 a2, a1 a2. Then you go to constant term and then you write a1 a2, a1 a2 and b1 b2, b1 b2, and now you multiply in the similar pattern. So if I have to represent x, I'll write x divided by b1 c2 minus b2 c1 equal to y c1 a2 minus c2 a1 equal to 1 divided by a1 b2 minus a2 b1. So there are different ways for you to remember. You can pick whatever makes easy for you. Now I'll go to an example. So let's try to solve pair of linear equation 2x plus 3y equal to 46 and 3x plus 5y equal to 74 by cross multiplication method. In this case, the given equation 2x plus 3y equal to 46 can also be represented as 2x plus 3y minus 46 equal to 0, so that I can represent them in terms of a1 x b1 y plus c1, and 3x plus 5y equal to 74 can be represented as 3x plus 5y minus 74 equal to 0, which is a2x plus b2y plus c2, right? Now, in order to solve this by cross multiplication method, we'll use this diagram. So we'll write xy1. So when I'm writing x, I'll write b1, b2, which is 3 and 5. Then I'll write c1, c2, which is minus 46 and minus 74. Then I go to y, I write c1, c2, minus 46, 74. I don't write it, I really utilize it because it was already there, right? So now, next one will be a1, a2, so 2 and 3. Then I go to constant term and I use 2 and 3, which was already there, and I write a1, a2, b1, b2. Now I'm ready to write the equation, right? So I can write that as x divided by 3 multiplied to minus 74 minus 5 multiplied to minus 46. Y divided by minus 46 multiplied to 3, which you can see here, right? Minus 74 multiplied to 2. And now 1 divided by 2 multiplied to 5 minus 3 multiplied to 3. Now you can simplify this. It gives you x divided by minus 222 plus 230. Y equal to minus 138 plus 148. And 1 divided by 10 minus 9. If you further simplify this, what you get is x by 8 is equal to y by 10 is equal to 1, which then gives you x equal to 8 and y equal to 10. So this is how you solve a pair of linear equation using cross multiplication method. Thanks for watching. You can visit us on www.classisfun.com.